Welcome back to our sequence review, day 2. Last night we focused on explicit and recursive, and tonight our main focus is on series. So one of the main things that we talk about when we talk about series is something called summation notation or sigma notation. So that's what you can copy right down, summation notation or sigma notation. We use the Greek letter sigma, so you should know this by name, and it is used to indicate a sum. Okay, so this means sum, which of course means add. So given the sequence, we can write the sum of the first n terms using this notation. So basically when they say k equals 1, I'm going to replace all my k's with the number 1. So that's the first thing I did. This was a sub k, I substituted a 1 into k. Then you just go up in order. So after 1, I plug in a 2. Then I plug in a 3. Now because it means sum, in between each of those terms you have to have a plus sign. Now, when do you stop? Well, that's what that top number indicates. You would stop at whatever number is there. In this case, it's n. So again, a similar example. Given this question, what does it mean to actually do? Take 1, plug it into n. So 2 times 1, then a plus sign. The next number would be 2 times 2, then a plus sign. 2 times 3, and I'm going up until that 5th term. After you do that, you want to make sure you add all your terms together. Find the sum of the first 12 terms. So one thing you need to take away right off the bat is it says sum. When you see sum, you are now doing something called a series, and you're using that sigma notation. Okay, so that's indicating sigma notation. So the first thing you have to do is write the explicit form. That's why we practiced those yesterday. So you have to determine if it's arithmetic or geometric. So you're either doing the second term minus the first term to see if it's a difference, or the second term divided by the first term to see if it's a ratio. So if I do my second term is 7. 7 minus 4 is equal to 3. So my question is, are each of these different by 3? And in fact, I think they are. I'm adding 3 each and every time. So I would say this is arithmetic. So I can use the formula off the sheet, a sub 1 plus n minus 1 times the difference of 3. And I'm just going to clean that up. So a sub n equals 4 plus 3n minus 3. A sub n equals 3n plus 1. Now that you have the explicit, you can put that into the summation notation, and it wanted the first 12 terms. So I'm going to find the sum or add term 1 to 12 of what? You're not putting an equal sign in here, you're putting the explicit rule, which is 3n plus 1. Now, if you have a calculator, and this is multiple choice, you are welcome to type it in the calculator. I believe it's something around, and jot it down for yourself, alpha, and I'm just going to say top row. You can look for it, might be alpha window, alpha trace, it's one of those in the top row, and you'll see the summation that you can type in. But if it's not, if it's short answer, you have to do this by hand. So again, let me reiterate what this means to do by hand. I'm plugging 1 into every n. So 3 times 1 plus 1. Then you put a plus sign because sigma means add. 3 times 2 plus 1. Plus 3 times 3 plus 1, etc. And you go up until 12 in order. 3 times 12 plus 1. Then you take all of those terms and add them together. Okay, so we're going to try another summation notation term, and in this case, you cannot type this into your calculator. And the reason, and you can make a note to yourself, is that there are 2 variables. And when there are 2 variables, your calculator doesn't understand that. It understands x, and that's about it, 1 variable. So notice I'm not picking which variable. It's telling me substitute 1 into x. So I'm going to get a minus 1 squared. Summation means there has to be a plus sign. A minus 2 squared plus a minus 3 squared, and then lastly plus a minus 4 squared, stopping at 4 because that is the upper limit. Now, what does it mean to square? A square, of course, means multiply it by itself. It does not just mean randomly square a term. Multiply it by itself. So I've got a squared minus 2a plus 1 plus a squared minus 4a plus 4 plus a squared minus 6a plus 9 plus a squared minus 8a plus 16. Now I still need to add those terms together. So I'm just going to take all my a squareds. So a squared, a squared, a squared, a squared. That makes 4a squareds. Negative 2a, negative 4a, negative 6a, negative 8a. Make negative 20a. And then 1, 4, 9, and 16 make a positive 30. And now I have my final answer. I just found their sum. Okay, now we get into the geometric series. Notice that was for arithmetic that we just covered. Geometric is actually nice because it just gives you a formula, and notice it's on your reference sheet. Okay, so this is when that reference sheet comes in handy, is for these sequences and series. And it describes it. S sub n is the number, the sum of the number. A sub 1 is obviously the first. R is the common ratio. So this only works for geometric because of that common ratio. Now, the one thing I notice people miss is if your word problem says increasing, your R value is going to have to be 1 plus the rate. And if it says decreasing, your R value is 1 minus the rate. Okay, just like in all those exponential problems. So when I attack these questions, I basically ask the big question to myself. Am I looking for a sum or a term? Another word you might see for sum is the word total. Obviously, that means that's a sum also if you total something. Or, like I said, just a very specific term. And that's how you have to attack each of these.
An auditorium has 12 seats in the first row. Each row has 2 more seats than the previous row. So I think we can write that out and picture what it's saying. So row 1, which I'm going to call A sub 1, has 12 seats. And row 2 then has 2 more than the previous, so I would say that has 14. A3, 2 more, has 16, dot, dot, dot. Hopefully you can see that it's arithmetic and we're adding 2 each time. So here's our first question. How many seats are in the 15th row? So remember, that big question is, are they looking for one term or are they looking for the sum? If I just said how many are in the 15th row, I don't want the sum of all of them. I just want to know the term of the 15th row. So what I want you to do is I want you to circle that word term on your paper, and then we can make a little arrow and say that means explicit. Okay, I'm not using the summation. I want the explicit formula when I see that word term, or I'm thinking term. So pretty straightforward from yesterday, I hope. A sub n equals A sub 1, which is 12, plus n minus 1 times the difference, which we said is 2. So you are free to clean that up. So I would say that's 12 plus 2n minus 2. So that's 10 plus 2n. And if I want A sub 15, or the 15th row, I'm literally just plugging in the number 15 into all my n's. So A sub 15 should get me 10 plus 2 times 15, which is 10 plus 30. So I would say that there are 40 seats in that 15th row. Let's continue on with part B. How many seats total are in the auditorium if it has 22 rows? Do you see how this question is different? It now wants underline that keyword for yourself, the total. If you find the total of something, you found its sum. Okay, so if I want the 15th row, I'm going to use the summation formula. The 22nd row, I want the sum of all of those, so I'm going to say n equals 1 to 22. So I want from the first row up until the 22nd row added together, and all I'm putting next to my summation is whatever that rule was. I'm not putting the equal sign in, I'm putting the rule, 10 plus 2n. Now remember, if you have your calculator, you can get this answer very quickly by hitting alpha, and then again something on the top row. I can't remember if it's window or trace. Obviously hit them and you'll see that summation, and you can type this in. You can use x's instead of n's. Let me remind you to do this by hand. You are doing 10 plus 2 times 1 plus 10 plus 2 times 2 plus dot, 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 and you are going up to 22 and adding all those together. Okay, next one, probably a very, very common question here. Sarah earns $33,000 in her first year of teaching and has a 4% increase each successive year. So what I want you to do is highlight this word increase, and that's the one thing people keep missing. Make sure we actually increase something. Increase means you have to add on, so I want you to make a note. That's 1 plus the rate. If it's a decrease, it would be 1 minus the rate. So part A. Write a geometric series formula, S sub n, for Sarah's total earnings over n years. So this is no longer arithmetic because it's increasing by a rate of 4%. It has a common ratio. So we are now talking geometric, and they also told you that. So I pulled up the lovely piece off the formula sheet, and I'm going to use this formula because it is geometric. So let me remind you, this only works for geometric. You have to be smart enough to use that formula sheet and look at it. It should be right in front of you on the exam. So A sub 1 was $33,000 minus $33,000 times the rate. And again, that ratio was 4%, but it was an increase. So it's 1 plus 0.04 raised to the n, all over 1 minus 1.04. So I want to be very clear. I'm not using 0.04 because of the word increase. I had to increase it. So 1 plus 0.04 for that R value. Okay, now they're probably not, if you look at your reference sheet, they're not going to give you those on the test. You have to understand what they stand for. And all it did was ask me to write this equation. Now, just want to be clear, we gave you a formula sheet at the beginning of the year. We do not have extra copies. They've all been taken. So if you personally lost yours, you can Google it, type in Common Core Algebra 2 reference sheet, print it out for yourself so you have it for Friday's test and in class tomorrow. But I don't have any extras laying around anymore. Everyone's taken them. So we'll keep scrolling. Use this formula to find Sarah's total earnings for her first 15 years of teaching to the nearest cent. So I'm basically just going to take that formula, and it says 15 years, so I'm going to replace my n with 15 and just substitute that back into the calculator. I want to be clear, I'm typing this all in at once. You're going to use that alpha window to get that fraction tool, and you are literally typing this in all on one line. You cannot, and I repeat, subtract these two numbers at all. These are all glued together by multiplication. So the easiest way not to screw that up is just to type it all in the calculator. And once you get that, you will get Sarah's total earnings for this first 15 years of teaching. So I'm not going to do that math for you. You all have a calculator and can figure that out. So I think this covers all of our series, and we look forward to some practice tomorrow.